The tale of semiconductor evolution is nothing short of a technological odyssey, marked by transformative milestones that have redefined the contours of modern civilization. Let us embark on an elegant reflection of this journey, beginning with Intel's groundbreaking 486 and Pentium processors, and culminating in the ascent of TSMC and the globalization of the semiconductor industry. In 1989, Intel unveiled its illustrious 486 processor, a creation born of unparalleled innovation and manufacturing expertise. Harnessing the then revolutionary 1 mm process technology, Intel succeeded in miniaturizing transistors, thus bestowing this processor with remarkable performance and power efficiency. With a staggering 1.2 million transistors, the 486 introduced novel features such as pipeline processing and an integrated floating point unit, FPU, not merely advancing computing, but transforming the very fabric of the personal computer market. This processor played a pivotal role in propelling PCs into homes and offices worldwide, marking a turning point in the digital revolution. During the 486's emergence, the semiconductor industry was still in its nascent stages, characterized by a vertically integrated model where companies like Intel managed both the design and manufacturing of semiconductors. This approach was indispensable in maintaining technological dominance, especially as the late 1980s and early 1990s witnessed an unprecedented surge in personal computer adoption with the 486 processor at its core. Fast forward to 1993, and Intel once again set a new standard with the Pentium processor. Utilizing 0.8 mm process technology, the Pentium pushed the boundaries of performance with its superscalar architecture, capable of executing 2 instructions simultaneously, and a 64-bit data bus that accelerated data transfer speeds. These innovations cemented the Pentium as the benchmark for high-performance computing, further entrenching Intel's market leadership. The journey continued with the advent of the Pentium MMX in 1996, employing an even finer 0.35 mm process technology. This iteration not only enhanced power efficiency, but also introduced a new instruction set tailored for multimedia applications such as video playback and 3D graphics processing. It was during this period that the semiconductor industry began to expand beyond traditional computing, venturing into multimedia and networking domains, thereby laying the groundwork for the vast technological ecosystem we witness today. The mid-1990s also heralded the rise of TSMC, a Taiwanese powerhouse that transformed the semiconductor industry with its pioneering foundry model. By concentrating solely on manufacturing and delegating design to fabless companies, TSMC spearheaded a division of labor that would become the industry's new paradigm. This model not only fostered specialization, but also played a crucial role in the globalization and diversification of the semiconductor market. In the present day, semiconductors are the linchpins of numerous technological advancements, from artificial intelligence and autonomous vehicles to 5G communication. The latest processors, crafted with 3nm process technology, integrate billions of transistors, a monumental leap from the 1 mm technology of the 486 era. This relentless march of process technology continues to be the driving force behind the exponential improvements in semiconductor performance. In summation, the development of Intel's 486 and Pentium processors stands as a testament to the company's mastery in process technology and semiconductor manufacturing. The ascent of TSMC and similar foundries signified the dawn of a new era in the semiconductor industry, an era that has positioned semiconductors as the bedrock of modern technological innovation.
Knowledge is power.